Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is more ping pong, where I hope to be continuing off of the stuff we did last week, where we started kind of making this game and storing all the state for the game in some kind of texture. Just as kind of a fun experiment to see. I don't know, is this thing possible in the tool? The answer is yes. So pretty cool. By the way, I'm a little slow today. I ended up spending had a long weekend from work because our team just released some stuff this last week, which is awesome. So I've been a bit distracted by, working on some other random stuff that I don't want to talk about, but might be something for Social Games, so we'll see. Anyway, should be pretty cool. By the way, hi to guys in the chat. I'm seeing John Hunter, Baggers, Pokey or Pookie, I don't know. Alkama, Daniel Collin, Zokwar, how's it going, guys? Anyway, so where we left off is we got basically the state loop working and everything. It's really not much code here, so that's pretty cool. And the ball's bouncing around the ball, and it also bounces when it hits the walls, so pretty rad. New LEA? New Lea? Not sure. Anyway, how's it going? John Hunter Nyson's excuse me, jeez. I've been away from people for a couple days, so I'm bad at talking. Worth it. Anyway, John Hunter 9 says, Nova, I believe you're asking if I'm thinking about the demo party or going to the demo party. I'm not going. Hoffman is going. That's all I know about that so far. But yeah, so first thing that I wanted to do, I was originally going to be working on the game logic and stuff, but as I'm looking at this, I really want this ball to be round now, so I'm going to go ahead and fix that. Hey, Evil, how's it going? So I'm just going to do that really quick. Pull up the right window here. There we go. Move some windows around. Get a little more out of there. This up as well. Now I gotta restore the state. There we go. Cool. Okay, so all I'm gonna do right now is just change the rendering. We'll treat it as a square ball as well. I also want to change the size a bit. But we're gonna still treat it as a square in terms of like collisions and everything, but I'm just gonna make that render as something round. Evil says the Pong ball is square. I guess it's less authentic if we fix that. But I really want it to be round. Hey, Pelicus. Hey, Metal Voids. So I'm just going to fix that. So this is actually pretty easy. Because all we can do is we can basically treat it as a 2D distance field. So instead of checking the position like this against the sort of the two axes here, but then positive and negative, and checking against the ball width, we can actually do this if the distance from the pixel pause and the ball position is less than or equal to the... Now, the only problem here is that it doesn't include ball width and ball height, but that's fine. I might just change those to be ball size. I think that should work. Yep, now it's round. That was easy. The only thing... That's why we had ball width and ball height here, isn't it? How do I want to do that? So this works, but the thing I'm thinking about is that it doesn't do the like left and right scaling properly now. So I'm wondering how I should do that. I could probably scale. 109 is distance field. Where would we be without him? Hey, Live Like Semtex. I think... How do I want to do this? Wonder if I can describe Let me try to think here. But avoids, yeah, I'll probably add that as well. I'm wondering if I should just get cheeky and do some funny scaling with the pixel position, because that would actually work. The other thing with polar chords is that I actually don't think that makes it more... Like, we could adjust the radius based on the polar angle. But I actually think I can get away with it by remapping the pixel position. And that's at least easier for me to think about. So I'm going to go ahead and do that, actually. What I'm going to do here is we'll do ball scale X, ball scale Y, like this. And actually, I didn't realize I did actually have ball size here. Let me make sure I can see my terminal in case I mess anything up. So what I'm going to do is, this is the scale for the X and the Y. Now let's do this. We're going to remap the pixel position by scaling it relative to the ball position. So we take pixel position minus the ball position, and that'll give us the position relative to the ball. And then later we're going to add back the ball position again. But then we want to scale this. I think that works. And then if we do this, it works. That was easier than I thought, so that's nice. In fact, let's add a little more as well. Those ball scaled pixel pause, which is kind of a funny name, but makes sense for what we did here. Cool. That was easy enough. Now I think I'll make a paddle, because I really want to get some game logic now, and then we can make it render all weird. Do whatever. In fact, the nice part about this is that generally, because the rendering is so separated from everything else, we might even throw up a little ray marcher or ray tracer or something and just render the game in 3D, because why not? Maybe. Anyway, first I'll work on getting the logic. So let's do, yeah, these are the states, and this is just a size. Let's do some kind of paddle size. And then we need positions for the different paddles. And I think what I'm going to do is I'm going to add 2 paddles, and I'm going to see if I can just make them play against each other. We'll do that first, and then we'll make one of them player controlled by using the mouse. Try that. I think that'll work. should do it. And for the initial states, we'll just set these both to 0. I think I'm also going to encode the X position here, and then we're just going to adjust the Y position. I think that makes sense. That'll be easy at least. Or, yeah, I think I want to do that, or I can make it in common and make those static, which is actually, that probably makes the most sense. Let's do that, actually. Yeah, looks like I did the other paddle position wrong. That'd have been fun. Thanks, guys. Yeah, let's actually just do the Y position here, because that'll be, we can just hard code the other stuff as a constant in here. Then we don't have to worry about messing it up or anything. Yep. What a voice. This is the fanciest tool to create Pong ever, isn't it? Oh, I think I've seen worse. Yeah, here we go. Do this. I hadn't realized we don't have the resolution here, and we kind of actually want to move the paddle relative to the resolution. I mean, could have done everything in normalized chords, but we'll just do this. So actually, I think I will encode the X positions in there as well in the initial state, because we have to reset that anyway when we move things around. So, or when we like resize the window. So I think that'll be fine. So let's do this. And this is vec 3, so we need to do this. I mean, actually what we should do is this. I think that makes sense. Actually, I think the ball is still doing everything relative to the center of the screen. No, okay, I did it here. Okay, that's actually better. Let's do that. Yeah. Oops. No, this does make sense. Okay. Sorry, just thinking. Or rather, not thinking out loud. Yeah, that's wrong there, because we need this. Actually, this will be res.y over 2. I should do it. So there we have our paddle positions. And in updates, we're going to do this. That. And then we're going to go ahead and read those positions up here. Okay, so that should do it for update, even though they're not going to be doing much here. But that's fine. Because I think, yeah, we actually want to render these next. It's going to make the most sense. So let's go ahead and read in the state in that shader. And yeah, then we'll draw this. And I kind of liked actually doing it this way with the distance field like this, so I might do that for the paddles as well. So we can do, for example, if we take the pixel position minus paddle 1's position, but avoids, you're going to be creating epic soundtrack for this too, aren't you? Yeah, when we get to the sync, that'll be pretty wicked. Now, I don't have facilities in this tool set up for doing any kind of GPU synth, but depends on how far I want to go with this. I probably won't work on this further after this episode because I just wanted to kind of try it, not take it too far. Although I've seen some of the ones on like Shader Toy that actually do, because they have facilities for doing sound synthesis as well in the different passes. So I've seen people do that, and it's pretty cool. But no, I don't think I'm going to do that. So if you take these two distances .x and we divide that by the paddle size x. In fact, actually, if we do this, or actually, yeah, I think that's actually it for checking that axis. We'll make it a different color, so just so we can see that. Yeah, there we have a paddle. Although, is it? I can't really tell. I want it to be kind of off the edge of the screen. Although it's quite possible we just didn't set the initial state. Yeah, there we go. At least the position makes more sense there. Still, though, not where I want it to be. And of course, we haven't rendered the top and bottom yet. I'm actually going to do that now. We'll just do this for the X, and then we'll just do a different one for the Y. Not actually that fancy in terms of distance fields here, but that's actually what I wanted to see here. And I think this is what I forgot. I forgot an abs here. Should have given us that, and then we need to actually... So what I'm actually going to do here is I'm actually going to divide this. Because... Actually, easier way to do this is just to make this and, because that's actually what we wanted. There we go. There's a paddle. Now we're going to render the other one as well. Sweet. There's the paddles. So now what do I want to do? Let's do collisions here. Actually, I'm going to make these follow the ball first because that'll make it a lot more useful when testing the collisions. Yeah, I think that makes sense. Now the next part is this thing here will basically work for collisions as well because we can basically do the same math against the ball. Yeah, but I wanted to do is, yeah. Sorry guys, really scatterbrained today. But that's how it goes sometimes. So here's what I want to do. We want to basically have the paddles just move closer to the ball. So it shouldn't be that tough. If the ball position, do I have that in? Yeah. Is greater than our paddle 1 position. And of course, we measure everything relative to the center of these, so we really should just have to compare the positions. So this is just going to be trivial here. And now the red one should follow it. Not too bad. I'll get the blue one to follow it as well. Oops. I don't know why I'm flipping that. Now this ball is moving super fast. So we got some exciting action going on here. Cool. Super basic. Actually, we weren't going to move this one because we want to actually update that with the mouse position. So what I'm going to do is I'm just going to add the mouse support now before I do collisions. Let's see. I think the way I had this set up is I should just be able to take this in as a uniform here. Ferris Makes Demos episode 40, adding collisions to ping pong. Totally. Yeah, we need to get the mouse position in our update state thing here. So I'm just going to go ahead and add a couple more uniforms here. And this will be mouse X, and I think mouse X is the hard-coded variable that I have for that. And I know it actually is because as soon as I finished typing that, it actually worked, which means it compiles. So then we should have those variables in the shader. The next thing I'm going to do is actually use these. Although I don't actually have... Oh, I guess I kind of do have this being updated when the mouse clicks. So the mouse position is a normalized position within actually this entire viewport, which isn't going to matter because of the aspect. As long as it's wide, it's actually okay. And basically, whenever I click and like drag around in this viewport, it's going to update that variable. And then we can get that in the shader. Or actually, in this system, we can get it in, and then using normal facilities in there, we can pass it to the shader. Now, it only updates when I click, but that's actually fine, because we'll just click and drag when we play this. So, it should be pretty easy. I think all we actually have to do is just set it to this. So we just say... Another thing I'm not doing yet, by the way, is limiting the positions here. So we're going to go ahead and take care of that in a sec. But for this, I think we just take mouse Y times res.y. I want to multiply it by the resolution because, again, these are normalized. So there we go. Then we have mouse control. Fancy. Now it doesn't. We don't know if the mouse is clicked in this system right now. And again, it only updates when I click, but this works well for this use case. So now we want to limit these. Now we have the paddle size here, so that should be all we need. Actually, we'll do it on this one because I can control it easier. So let's just say. And why don't we do this stateless? That should take care of the bottom. That should take care of the top. There we go. So now it's all limited. We can just do the same here. I don't mind just copying and pasting for a lot of this stuff because whoops. Yeah, we need this. There we go. And now this won't be able to move past the top. Nice. Software says mouse X can control the other paddle, and then I can play with myself. And just get super frustrated. Let's do it, though. I'm going to hate this. Oh, good. Oh, I knew I would hate this. Like an Etch-a-Sketch. Yeah, I'm going to put that back. Now, the interesting thing here is that now that we've kind of gotten the framework here, actually doing this like game logic and stuff is really just basic. So basically literally just doing a lame Pong game now. Here's what I want to do for the collisions. The easiest way to do the collisions is we can just check the if the velocity of the ball is going a certain direction against a particular paddle, and then if it's X and Y stuff, it's within range. That'll be the easiest and probably the most stable, because it'll keep us from doing cases of like slicing the ball like that and then the ball just getting stuck in the thing. And that should be easy enough to code, so I think I'll do that. And then we could do some kind of score, although I don't know how I can render it. Because we would have to get it out. I mean, I guess we can do the conversion from the score to decimal and then render distance field numbers, which would be ridiculous. I don't think I'm going to worry about that. I think actually, just because I want to wrap this up today, I think I'm going to do the collision detection and just have the ball bouncing back and forth. And then I think I'm going to be satisfied enough with that. And then let's just do some rendering shit. Yeah, I could actually also render scores as like horizontal bars. I can just play to 10 or something. And when you get there, it just resets or something. So I guess I could do it that way. But it'll be more fun to just tack on some random shader effects at the end of this instead. So what I want to do is we'll do in the ball update. So we need it in the wob. The velocity needs to know about it. And the position needs to know about it. So let's do this. Middle voice, you talk on the ball in the graphic settings. Dear 2, it's so cool to watch you create a game in shaders. Oh, thanks, man. I mean, at this point, it's a lot less cool, I think, because we did kind of the interesting bits, but that's still kind of neat. So we're going to start with this. And the reason I'm doing just a full function like this is I think it'll be, yeah, we can bake like the velocity checks in here as well. And then we can just call this function multiple times. Like it'll reduce the bootstrapping, even though we'll have to have a little more logic inside this function specifically, but I think it'll be okay. We'll do vec2 ball position. We'll do vec2 ball velocity. We'll do, then we just need the position of the paddles. Yeah, I think that makes sense. And then this becomes fairly easy because we can do stuff like early out. So if the ball's traveling to the right, we know it's not going to be a hit, or at least we're not going to accept that as a hit. I generally like to write it like this, where it's like at last it's true, and we're just going to early out with a bunch of these conditionals here for the cases that it's not a collision. I think that'll be a little bit easier to describe here. Let's see. I think we just need... So we can check the... If ball position.x minus paddle position.x, if this... I'll just do abs there so we can use the same logic for the other one. It's less than... Then we need the ball size divided by 2 plus the paddle size dot x divided by 2. So actually, we're going to invert this. If it's not within that range, we're going to return false, and then we can do the same thing for the y, basically. Think that makes sense, but we'll debug this if it doesn't. Then we're going to actually use this. The other thing I'm going to do here is sort of generalize this a bit, because we're going to need it for both. Because this is all the same here. I think the only difference is the velocity check. That should be about it. And then we can even... Actually, it's all the same, because we can just generalize this. The only difference is if we want to incorporate score, which I'm not going to do yet, so we'll just generalize it like this. Yeah. And then this becomes pretty easy. So then in the wob, if the ball intersects the paddles, so we're going to do the ball position, the ball velocity, the paddle 1 pause, paddle 2 pause. Then we just say ball wob dot x is 1. And it looks like it already works. Because you can see the ball wobble early there, it looks like. Normally I do mind backseat coding, but I do appreciate that. Thanks for the help. Yeah, so we can see the ball wobbles early there, which is what we're after. So the next thing we're going to do is, so that takes care of the wob, but then we need the velocity. So we can just use the same check here. Whoops. I just copied that whole thing. I did, didn't I? That's fine. There we go. Boing. Not too shabby. And we don't really need to do anything with the position. So this was nice. Now, it's not the most proper detection and response that we could have, but it's not too bad either. Good enough for the purposes of just this little experiment, at least. Yeah, I'm honestly satisfied enough with this game logic. That, like, this is as far as I wanted this experiment to go, actually. So now I can just start messing with stuff. The ball really big, or it's more exciting if it's smaller. Actually wanted the paddles to be a little bit taller. May have to do the initial state as well to get the proper X positions. And I'm going to make the initial ball speed a little bit faster again. It's actually a little too fast for my opponent there. Although I tell you, it wouldn't be too fast if we're doing mouse position for both of these. This is actually really disorienting to play like this. But what I'm realizing is actually you can kind of pick it up pretty quick, because like if the ball's traveling to the right, you just move up and down. Otherwise you move left and right, and you can just wiggle a little bit to calibrate. So that was actually kind of neat. Let's go faster again. You also can change the ball speed related to the number of paddle hits. What I can do, the easiest way to do this, I think, is just multiply it by a little bit every time it hits. So in the case of the velocity here, we can just do times 1.1, for example. Now this should make it go faster every time. Not by, well, by 10%, so this will compound. Now it's getting pretty fast. So that's pretty good. I think what I'm going to do as well is, in this case, when the ball hits the wall, we can just reset the initial state. Which, just going to make this cheap. Uh-oh. What happened there? I think it hit both of these. Oh, also we need to do this check here. Because there I just made a classic writing a game in shader mistake. That I thought I could update two states at once. However, I totally merged the wrong checks here. so we can remove the velocity checks here. I'm not actually sure if this is resetting the velocity properly. I don't think it is. This seems like it's accelerating to me. Instead of clamping max speed, I want to figure out why it's not resetting properly. Be better, I think. Thanks for the suggestions, guys, but I think I'm going to fix this one bug, and then we're going to, instead of trying to make a more interesting Pong game, which, not the most exciting thing in the world, I think I'm just going to start lathering it up in shader effects. I think that'll be more fun, for me at least. But I really want to figure out what's causing this, at least. I would have expected this to happen. Maybe it's just that it's being overridden by something else. Apparently not. So we don't need these extra parens here. Now we're actually missing the collision because of this. It's interesting, though, because I wonder, like, the thing is that we have, like, when you're writing normal game logic like this, you'll have cases where, like, you'll need to do a less than and greater than here, and then like a less than equal to and a greater than equal to down here. And the reason is because this will reset the position before this code gets executed and then adjust the velocity. But in this case, it's all happening at the same time. So I actually find it really odd that we would have to do any kind of difference like that. So I don't think we should have to. So I feel like the same condition here that's going to reset the ball position, which, just to be sure, I'm going to do it last so it takes precedence over the other changes. Yeah, it shouldn't affect that, but I just, actually, you know what? I think this is why, actually. That actually does make sense, because this one's checking against the ball position that's been adjusted by the velocity already, whereas this one's just checking against the ball position. So let's do this. Let's actually move that bit of logic out here so that both pixels that are updating those states will be looking at the same thing. And there it looks like it got fixed. Now I just want to see it get faster again, which it looks like it's doing. And then resets there. I think that's pretty good. One of the things I do want to do, though, is when it resets the velocity, very simply, I'm just going to do this. Whoops. Yeah, it's here. Take the sign of that. So if it goes on the other side, it'll continue that side. Tiny little change. Anyway, that was my little rant that ended up finding the problem. Good enough. And we can also do the sign of the thing as well. Does sign work on gen type? Because then we can just do this. I don't know if it does, though. Oh, it looks like it does here, at least. That's the kind of thing that wouldn't work on ATI. Doesn't seem to be behaving as expected, though. Let me look this up. GLSL sign. It's supposed to work with gen type. By the way, when I say gen type, that's just the, like if you look at the manual pages, the reference pages for GLSL, gen type is what they use to say, like it's some generic float or vector type. So when I say I don't think it supports gen type, I'm assuming it probably only works on floats, but that seems to be incorrect. I'm wondering actually. Oh no, this is actually working. I don't know why I assumed it wasn't. But it's definitely working. At the bottom, yeah. Okay, never mind. That totally works. Cool, so now the game logic is basically done. At least done enough, I think. So now we can start messing with rendering and stuff. I think that'll be fun. So, easiest thing to do here. Nice thing is that we have everything in this in this one shader. And we just output to this color variable, and then we can just start adjusting it. So for things that don't actually need like spatial distortions, we can just change the color here. The other nice thing is that because this is a completely separate pass from like the state updates and stuff, we can just change like the pixel position and we'll get spatial distortions. So for example, if I want to, actually, do we have a state for the game time? Yeah, we do. Nice. The reason I'm asking that is because we can do things like pixel position dot x plus equals pixel position dot y, and again, this only affects the state for like this one pixel, this one shader. Won't actually feed back into the state. So we can do this. We can take like the sine of time plus this y times 20, and then we'll get this kind of weird stuff. This will make it a little more exciting to play, at least. Nice, Hunter. Following along in Scratch. The cool part about an effect like this is I can do, for example, times the length of ball wob, which should... Oh, it's red later. After we read all the states, and then then we get this kind of wobbly effect when the ball hits stuff. That's kind of fun. And what I want to do is I want to have a more interesting sort of plasma effect here. We can adjust the y as well. But we'll want to adjust it with different values than the x. So cosine, which will adjust some phase. We can also add in some extra phase too. Especially if we change, add some extra numbers here. And we'll adjust that by x as well. That's some random stuff. Actually, let's add in both x and y to both of these for fun times. Just to mess all this up. And then we'll do some POW stuff here. This will do Saturate the paths. I need to make saturate. Just do it in here. And then we'll stick a number in this power to actually make that make sense. This will just make the shake thing be kind of quicker. Bang. That's kind of neat. Hunter, was that 1.4 or 2? Oh, no, you're asking about scratch. I thought you were asking about constants I'm typing in. Like you're following along to that degree of accuracy. Let's mess with the color as well. So for example, we can take the... Let's actually just make everything white again, because that was kind of cool. We can add a little vignette, which is really easy to do. We basically also going to actually change the background color a little bit. So I feel like that, making that more visible. You just take the color, we'll do minus equals the pixel pause minus res over 2. And we can take the length of that vector, which actually is the same as the distance between these here. If I do that, it'll get real dark. We're just going to add some divides here. So now I get some kind of ramp that basically goes from 0 to 1, but then we're subtracting it here. Now if I do the same kind of trick here where I can like raise that to a little power, we can kind of adjust the curve that this has. And the other thing we're going to want to do is saturate here. Divided by this. I think I'm actually just going to keep that kind of low and then just turn it down a little. So we get this kind of nice smooth curve. The other thing I can do is I can 1 minus this before the POW and then take 1 minus this after everything else. And that way when I adjust this power, we actually did not get what I wanted. I think this was actually correct, maybe. Just seemed to saturate up there really quickly. But that's fine. Gives this little vignette effect. Just kind of adjust these values until something looks a little nicer. It's getting a little better. Pong and LSD, exactly. Another thing I want to do, by the way, is I want to do some gamma correction here, which is really easy. Take this, divided by a gamma curve. That's why everything was so dark. And also now this looks more linear, which makes sense. Which is not what I wanted, though. Just kind of adjust this curve until I don't hate it. This is what I do when I code shaders. I just sit here, tweaking everything, regardless of how important this shader actually is. Come, always saturate your paws. It's important. One of the things I want to do as well, I actually don't like this pixel wob. I want to make it pixelated, and I want it to do RGB distortion. So how could I do that? I could make this multipass and do all the posts in a different shader, which I should probably do anyway if I want to add a couple other effects that I kind of want to add. However, just to be cheeky, I think I'm going to do this in the same shader. And the way I'm going to do that, render game. So I'm going to make this render game function. I'm going to let the compiler tell me which variables I didn't pass in here. I could just do some cheeky stuff here. So the whole reason I did this is so we can pass in a different pixel position. So if we want some kind of distortion between color channels, we can just pass in, we can adjust the pixel position differently, like make two versions of it that are adjusted differently, and then this should all just work. There we go. Now I'm seeing the errors I wanted to see. Feel like it's random val and bar restart because of that exclamation point. I'm not going to do it. I'm just going to let you suffer. We can be really cheeky here, actually. And adjust the pixel position in kind of a funny way. What I'm going to do is I'm going to do this. And that's going to need some other things as well. For example, time vec2 volwob. Like that. Now what we can do, we can have these different pixel positions here. And if I just adjust time, then we'll get a difference between these two. So this will probably just look like some kind of ghosting. But what I want to do then is this. And then we can do different color channels for this other one. Now I have some of that fun distortion. I'm actually going to add everything in this render loop here, like the vignette as well. So we can see that a little bit in the background now as well. And I'm also going to add this color here too. Now I want to do some kind of cheap scanlines effect. Those make me laugh. Really easy too. We'll just take a sine of pixelpause.y. Now if I just remap this, we'll get this. We're going to get like there's a couple problems with this. First of all, it's too strong. Second of all, we're going to get some kind of aliasing here because we need to drop this frequency down a bit. So we're going to get some of that, but I think that's okay. And then we'll just turn that down a bit. Actually, bring this up even. Yeah, I'm actually going to do this as well. Saturate the color before this. I don't really know why the petals aren't being affected more by this. Would have expected them to be, at least. Another thing I'm going to do here. Now, it's going to seem like this is really redundant that I'm checking the pixel position here. There's a good reason for it. Because I want to add this kind of radial screeny border thing. And I'm going to do that by adjusting the pixel position. So we can do like pixel position is pixel position minus res over 2 plus the pixel position. And of course, that's going to make it... Oops, we need to add the res over 2 again. That's what we need to add. So that the expression here gives us the pixel position relative to the center of the screen. And what I'm going to do, I'm going to move it sort of in the direction here. So we can do, how do I want to do this? Easiest way to do it, we can do length of the vector here. I'm actually going to do this. Whoops. Did not mean to go over there. do this, actually. I hit it. It avoids. I pause the screen for 5 minutes. When I come back, scan lines, more LSD effects. You're watching a demo scener play with shaders. Frankly, I don't know what you expected. There. That's actually what I wanted to do. I didn't want it to be this extreme, but that's fine. Oh, yeah, I did not want to saturate that. That's true. Because I want that to go out of bounds out here. That's fine. Oops. I think I did it again. Definitely not the highest quality version of this effect there is, but totally works. We can add a little flicker as well. That'd be fun. Chandra, I think this is now slightly out of Scratch's field of processing. Perhaps. Shader Scratch. There's your new website idea. Call me when you're a millionaire. Let's make everything slightly green and gross. And I think I actually want to apply this before the distortion. Or sorry, before the RGB separation. So you get that almost like the screen's messing up. And I want to make that look more like pixely and cooler. Which shouldn't be too hard, actually. Because if we just take the... or actually, I need some noise functions. Which I can just copy out of something else. Here's some noise. Here's some FBM even. Yeah, I have this rotate function in one of these, so I can't grab all of them, but I'll just grab a couple of these. Thanks, IQ, for the noise. Oops. Yeah, why not put those in common? That's fine. Okay, now let's do... x plus equals... And we'll do FBM of some vec3, where one of these is going to be time. And we can take the pixel pause.y times, actually divided by some number, and we're going to take the floor of that and multiply this by like 20. So right now I just want to test just to make this work. I'll just make this a big number. And then we can adjust this stuff. So now we're getting into the kind of stuff that I wanted to do here. And then we'll make this do the pixel wob amount here. Actually, I'm going to do this. Oops, times 20 times this. And let's make this more. Cool. Also saturate this FBM, and we can do times 2 minus 1, and that'll remap it to -1 to 1 instead of 0 to 1. So it doesn't always just go to the left. That'll kind of go both directions. It'll be a little bit biased towards one of the directions because the FBM isn't perfect. It doesn't have the greatest distribution over, but it's okay. Now it starts to look pretty cool. Baggers, if IQ cashed in all the beers the world's dev owe him, his liver would catch fire. I don't know, he is Spanish, so I think he could handle it. Pokey says, kind of reminds me of the CRT monitor degas effect. Oh, totally. That's the kind of stuff I want to go for. Just something weird like that. Might reduce this greenish thing now, because now the RGB separation is probably going to look a little cooler. So I think I want to have a little bit of this. In fact, I might even push it into the more blue range instead of the reddish range. But just need to make it more subtle. In fact, actually, that was kind of cooler as yellowish green. We need some distortion in the Y direction, of course, as well. What we can do is copy-paste. And I'm just going to take some of these. The nice part about having a three-dimensional noise function is you can just kind of like swizzle the inputs, and you'll get some different stuff. So that tends to be pretty convenient. I use that a lot. I love getting away with just making things not super ugly. A little bit ugly, but not super ugly. Then you don't have to make as cool stuff. You just lather it in post effects. This needs bloom, though. This definitely needs some bloom. So then we need to go multipass. Now, unfortunately, I don't have like proper copy and paste in this tool, so I can't just copy the bloom from the other thing. I can use the same shaders, though, which will be nice, and most of them should just work, but I'm going to have to spend a little time setting this up. So after render, we're going to make another subroutine here, which I'll call bloom. Going to need a couple passes here, because bloom. Yeah, this just normally renders into nothing. We're gonna want to render. So we need to set up a couple passes. We need to set up a pass that does all the gamma stuff, because we want to do that after the bloom. And then we need to set up a bunch of passes for the bloom. But for now, I'll probably just use one pass and then just do a stupid box blur or something just to test it, to kind of have an intermediate there. So we'll do that. But first, I'll set up the separate gamma pass. So we'll make another render target here, which, that one. And we'll call this gamma target. And the format, I actually want this to be RGB32F. Because we want as much precision as possible here. We don't need the A component, though. Just that. So then this one's going to render to that render target. And then, of course, we don't see anything now, which is fine. Instead of the bloom, I'm actually going to call this gamma, because we'll set that pass up first. And then we should be able to just set up this program stuff. So use the same quad shader, and we'll just call this Pong gamma. Now it's going to need one uniform, which is going to be just some texture. Render target name is going to be gamma target. And that all looks good. And then we're going to draw a quad there. We also need to set the viewport stuff here. Kind of the annoying thing about graphics programming generally is you have to set up so much state all the time. I forgot I had a RNG here. I totally don't remember where my viewport thing is. That's why I'm just sitting here fumbling. Yeah, this should work, but now we need to create that shader file so that my console stops yelling at me about how I can't find that file. So this should actually be basically trivial. I'm just going to copy this because I'm lazy. We're going to do Pong gamma. So now I have a pass. This text, we don't need any of this. We do want this. Get rid of all this. And it's going to be very simple. There we go. Now this is being so this worked, but the gamma is being applied twice because we applied it at the end of this as well. We'll take it off of here. Whoops, no, that was the grading. So we'll do it here instead. That's what we wanted. And I think I'm gonna leave this here as well. I think that's fine there. Yeah, I think this makes sense. So now we want to set up some kind of basic bloom. So we want to do that before gamma here. So set up another target. The ordering here is totally not significant, but I tend to prefer to keep these in the same order that I actually use them. I think that's a bit easier. Now bloom normally uses a few targets because we normally do a couple downscales. So we take the buffer and we downscale a couple times, and then we do some blurs on the downscaled version, and then we recomposite that blurred version on top of the original version. But we can just kind of take this one step at a time. Even though I have the shaders for this, it's just going to be easier for me to do it step by step. Make sure we have the right format. It's a bit wasteful using 32-bit float buffers for everything, but we live in the future, so gonna deal with it. So instead of the gamma target, we're actually going to render to that from there. Whoops. Actually, let me actually just look at the shaders I have, because if they're... might actually be okay. Yeah, the downscale is just a blit. And then we have a couple ping pong buffers with this little blur. Yeah, I'm actually just going to reuse this. So the bloom has a bunch of different pieces. I'm going to separate these into sort of different subroutines, but down here, I think. Now this is going to be really annoying because I don't have copy paste, but it's going to be okay. Something like this. Actually, we'll keep this over here. So we need quad. And I have stupid long shader names in this case, but test renderer bloom downscale pass. And the inputs that takes is basically text, which is all we really need here. So we can just pass that in here. For the bloom target. Now we also need to do our viewport stuff. And the quad. Now this, yeah, because that's actually just rendering the screen. So that actually makes, that output actually makes sense. But we need to add a couple targets here. We need a couple downscale targets, and we're going to downscale it in a couple steps. We're going to downscale it to width over 2, height over 2. And then we're going to downscale it again, so I'm just going to make both targets here. Hey, Anarchy. And this is going to be quarter width here. And that should be all we need for the downscale passes, because I think we'll downscale to half and then quarter res. I usually like to go down to eighth, and in fact, in this scenario, it might actually work really nicely, so we'll get wider bloom. But I'll have to hook more stuff up if I do that, so we'll just do a couple downscale passes. So actually, we only need one downscale pass. And then... Actually, we need two. We need two, because one of them will downscale it down to this target, and the other one will downscale again to another target. So actually, instead of having two downscale targets, this is where it's actually going to be the sort of ping pong blur target. So we'll do bloom blur target 1. And we'll do the other one here as well. This is the kind of stuff I really like having a tool for, because it's just going to catch me out as I'm writing this with all the dumb mistakes I'm going to make. So I tend to like this. I'm somewhat considering making a text-based language instead of the visual language here, because the visual language was kind of made thinking that one of my friends who's a CG artist might at some point be able to use this, but it ended up being a lot lower level than I thought, so I'm not really sure that that's that valuable. But at the moment, I'm not really feeling like I'm held back too much by the visual stuff, especially if I add things like copy paste and some other things. I think it'll become really nice. But, you know. I mean, the advantage of keeping things in text is that like good text editors exist, so it's kind of one of the least bad ways to represent information generally. But I digress. So we're going to want one of these to render to the bloom downscale target. But Avoid says maybe a mixture of both. Yeah, that might make sense. So we're actually going to, the second downscale, we're actually going to render to one of the blur targets. bloom downscale pass. And in this case, we want to take the text from bloom target. We're going to do the when I get it in the fingers, I start getting a little faster just entering these. I have key shortcuts for like every kind of operator, which is kind of a dumb way to do it, but it was a lazy way to set it up. And when I get in the zone, I can start like creating the right ones just kind of when I need them, and that's pretty nice, but it takes me a minute to get there. Anyway, these widths are wrong because this is going to be over 2. It's going to be over 2. Same with this one, as we're drawing to those lower depths. And then we need to do a couple ping pong passes. So what I want to do is set these up. So we'll do blur pass 1, pass 2. And so these are going to be our sort of ping pong passes where we take from one of the blur targets and blur onto the other one, and then take from the other one and then blur back. So each one of these is going to go from one to the other. And then what we can do is we can do the bloom blur, which is going to be a subroutine here. I'm just making subroutines just to have different stacks here because I still need to do the thing where I can actually make these wider and then just stack things underneath. But this isn't the worst thing in the world. And literally all I'm going to do is I'm going to have a repeat. We're going to repeat 10 times, and we're just going to call one and then the other. That's how we'll get our ping pong passes. Evil says bloom is hard. There's a lot of buffers when you do bloom. So it's just... Generally, that's what this means. If there's a lot of stuff in this grid, is it like there was a lot of GPU objects to set up to do this. But not the worst thing in the world. Yeah, and then at the end of all this, we're going to need a composite pass as well, which we can get to at the end of this. And that's actually what this is going to be. But it's going to need some additional textures here. So at the end of that, call bloom blur, and at the very end, we're going to call the pass. I'll call my threshold half resolution interpixel sampling. This is not going to be that tough, I think. Not going to be that fancy. We will need to do our own composite shader. I'll get to that in a minute. But I want to do these now. So this one we're going to render and bind this target. We're going to bind, so the downscale wrote to blur target 1. So in the first one we want to do, we're going to render to target 2. Using the texture from target 1. We're basically going to do that a bunch. And the blur pass here needs resolution XY texture, and it also has a direction thing, because this is going to be a separable blur as well. And that's what we'll do when we do the ping pongs. We'll alternate that. So that'll be fine. So yeah, so we need to set the text, which is going to come from blur target 1. That'll be fine. And then we need to set the resolution X and resolution Y. And then the direction. And I think I just did the direction. either 0 or 1, where 0 represents a horizontal vector and 1 represents a vertical vector. Yeah, that's exactly what this is. So then we only have to specify it with one thing there. Then we'll set our viewports. And then we'll draw the actual quad here. The next one is going to be basically identical, but with a couple of the parameters swapped. So we're going to render to target 1 again, using the same program. And then the texture is going to be the other target's texture. And then these other things are going to be the same, except direction is going to be 1 in this case. And then we're going to set our viewports and draw a quad. And then we need to do our composite pass. Now our composite pass, so in my normal render, I have the bloom and the depth of field being composited in the same pass, and I have a lot of parameters here. We're just going to hard code a bunch of these in this case, though, because that'll be easier. Where'd my Pong gamma go? We're just going to start with this. And just as a blit, you can see it basically already works. But all it's doing right now is taking the texture from the bloom target, which is the original texture, and then putting it on here. If we change this to be bloom target 1. Whoops, that was the wrong thing that I changed here. Here. Then we should get a blurry version. And here we can see I had the wrong format on one of these. Okay, looking good now. And then, of course, this is just kind of ridiculous because it's just the blurred one. But this will make sense when we actually composite this together. So for the texture, we actually do want the bloom target, the original one, unscathed. And then we'll take the bloom text or blurred text, and then this will come from the blur target 1, and then our composite can just do this. And we can say color. Yeah, also, by the way, we do not want to be doing gamma here. So that makes more sense. The color plus equals bloom. And this is basically where we want to adjust to taste. Now, I'm a bit surprised that it was that dark. Let me adjust something. Okay, I don't think we specified the right target here. Or are we not reading it correctly? Because setting the color to bloom here should have given us the blurred version. Ah, wrong uniform name. There we go. That's what I expected to see. And now we get this really wide bloom. Okay. Ehig says, is this all in RGB? This is in linear. Or, well, yes, RGB in terms of RGB versus HSB, but it's linear RGB in this case. And then we fix that with the gamma at the end. We don't do proper tone mapping on it, though. So we're going to want to do that as well. We can just bake that into the gamma pass. Right here. And I'm going to just steal that from my test render, tone map, and gamma pass. I have some tone mapping operators here that I'm just gonna slap on there. And we can do tone map. And then we have an exposure here, which is just gonna be 0. I think 0 was the right one. Maybe it was 1. This seems weird. No, exposure should be 1 here. But why is this weird? I guess because this 2D effect was applied before all of this. Let me play with some things here. I did not expect it to look like this. Oh yeah, the tone mapping actually has the gamma built in. I forgot about that. That actually explains basically all the problems there. Now, in this case, we wanted this. So linear in this case just means a certain kind of tone mapping operator that basically treats the values above 1 as in kind of a more linear way. Hable is actually like these are the more filmic ones. In fact, I really kind of like this Hale Burgess Dawson one. At least when you want to have more sort of extreme effects like this. But yeah, the issue is that I was applying gamma twice. So the bloom still goes outside of the little screen area here, but that's okay because we do the screen effect sort of before everything else. I think that's fine. I think I'm just going to leave that for now. I want to adjust the bloom a little bit though. I want to raise this to like a little power so we sort of darken the darks and brighten the brights at the same time, which I tend to like to do. I also like to bias this stuff a little bit. That is way too much. We can kind of like add more extreme curves and make this more extreme in the brights, which is generally the kind of thing I like to do with this. And then of course we're not going to want as much of this. Just kind of tweak these ramps. Another thing that you'll typically want to do is actually ramp before you do the blurs. But in this case, it's just easier if I don't do that. Anyway, this got kind of fancy. E. Hicks is so round, I must expect the ball to wrap around the other side of the sphere. Metal Voids, you're playing around with fancy shader effects when you didn't even implement scores. A true demo scener, exactly. And I'm not even gonna implement scores. We can reduce that screen distortion effect a little bit. I don't want to reduce it too much because I kind of like how extreme it is. Sometimes I like things to be a bit garish. But I do want to adjust that a bit. Where did I do that? It's here. I actually really like how extreme that distortion gets when the ball hits. Makes it feel powerful. Boom, boom, boom. Cool. Well, that's about as far as I wanted to take this little project. Kind of fun making a game in this kind of framework, even though, of course, the most fun parts for me are the graphics. That's what I'm into. Actually, you know what I want to do before I go is I want to add a little bit of static. And then I think I'll call this quits. Because it adds sounds. I can do that with my mouth, but as I mentioned before, I don't have the hookup in this tool right now, so I don't want to. Not going to do GPU sounds or anything. Could always pull this over to shader toy and do sounds there, but I'm not very interested in doing that in this case. But I am going to do some static on the screen here, which should just be a matter of adding some stuff here. I'm going to do it before the scan lines. And I think in the noise here, yeah, I should just have noise. That avoids dead bass. Baggers, leave the Virtual Boy running in the background again. I need to just wear the Virtual Boy and play Virtual Boy games now. That's what I need to do. Only more golf in our lives. That's a good point. I could put that on. But then I'd have to turn off animals as leaders. I'll do it. Why not? Let me set this up. We're getting meta on these streams now. It's not very loud. Perfect. I'm sure that's exactly what you wanted, Chris.
P and Esau present.
It's just locked up. The emulator just locked up over here. I want to put on some other Virtual Boy music, like Waterworld, which has the best soundtrack. And my emulator actually plays that song at the correct speed, so take that, Mednaffin. Yeah, we waited so long on the other stream for it to soft look like that, and there it just happened. Of course. Perfect. All right. With that, I think I'm going to leave you guys. This has been fun. Next week, I'll come up with some other effect to do or something. And on Thursday, more Virtual Boy stuff. I'm going to be digging more into Mario Tennis and why that doesn't work. But for now, this has been fun. So thanks guys for hanging out, and I'll see you next time. I don't actually have anything else. I just thought I'd play this for a little while. Thanks, guys.